Alright, this is Andrew back again. Video number 3, continuing on with the off-season robot design project. Hopefully the goal of this is you all learn something about designing robots. Last time we were here, I got a little stuck on how to handle an intake like this. I had not actually done it like this before, so I consulted a few friends. Asked them how they did on their robots during the season. My initial thought was a tube roller on the inside that would just ideally pick up the ball by rolling in towards the frame. It would be oriented vertically, so like you see this this piece, the circle. That's the circle right there. So ideally, that would be my original idea was it would be something down here, and then would shoot the ball up. The reason I was pretty hesitant was because I didn't think it'd be smart to have it that low below the frame. And I double checked my friends, and I was right. It is not smart to have it that low below the frame. But the interesting thing I found out was quite a few teams had with this style had their roller pretty far up, about 4 inches off the ground. So let me see. So my initial thought was, well, if I have 8-inch diameter wheels, then 4 inches, it's going to be a little below here. Oh, what do you know? That's 4 inches. Okay. So I'm just going to have mine, because I like really clean geometry. I'm just going to make this tangent here and tangent here. The outside circle you see, that's a 1.5-inch diameter piece of surgical tubing roller, the polyurethane, or I think it's polyurethane. I don't actually know the material, I just know how to design with it. And the inside one is a bearing, 1 1/8 inch outer diameter, just to see how it would fit. So it looks like it'll fit pretty nicely. My initial thought was to angle this corner, but kind of unsure about that now. I don't think it's going to be that necessary because I have the wheel sticking out this far. Ooh, another thing I need to think about. I actually did not think about this at first, but the bearing block is going to be something like this. So maybe this won't be as easy. It'll be as easy as I thought. So my original idea was okay. Yeah, so that's not going to work. My original idea was I just have my side piece of tubing and plug my bearing in there, call it a day. Then just have the rest of the tube go out. What I forgot, and I just realized now, is that my robot is going to be having an indent in the front. So realistically, it's not just going to be a rectangle. It's going to be a rectangle. Let me just add my center lines. It's going to be a rectangle with cutouts in the front and back. Because I think I am going to be able to go with dual-sided intake after all. Let me get that horizontal. Okay, cool. So I'm going to have a cutout just like this. It's going to be tubing making the cutout. And that's going to be clear of all the drive chains and all that. So that'll work out. And if you don't get what I'm saying exactly yet, don't worry, it'll make sense in just a second. So what I'm doing over here with this rectangle is I'm going to essentially model my drivetrain. Oh, okay, nope, not like that. But I'm going to model my drivetrain from the top view. It's always nice to do multiple views. Oh, okay, that's doing that. I'm going to give it a size so I can stick with it and move it around. Oh, nope, don't want to do that. Nope, don't want to do that either. Cool. My two teams have different different hotkey and control schemes on SolidWorks. So moving between them is interesting to say the least. It's hard to remember sometimes. But yeah, I think I have my distance. This equal to, say, that. So that's going to be the length of my outer tubing. And I could include the length that I have technically for my bumpers, and because it does go out a little bit further. For the purposes of just the drivetrain, though, I think I'm not going to model that right now. I may do it later, and in which case it'll be easy to add on. Okay, how far in this needs to go? Realistically, not far at all. So if my tubing is going to be 1.5 inches, I'll make it like 2 inches. Oh, and that dimension went away. Okay. Oh, it did not go away. I just was being dumb. So I'm just going to cut in right here and do the same up top. And I don't know if this will mess anything up. I hope not. Okay, cool. So the goal of that right there, nice, will be to show the opening for my ball and exactly how much room I'm going to give it. I'm choosing 11 inches as an opening size. May or may not regret that. I need to check in the design. It's 27 inches total. I mean, it may be alright. What's that put my perimeter at? Like, okay, what I have 33.5 and 33.5. That is 67 plus, what's my width? 27 and 27 is 54. 54, yes. Yes, okay. So I have 54 and 67. That's going to be... Oh, I'm great at math, I swear. Don't pay attention to me. I'm really good at math. Oh yeah, that's clearly 120... How is that too big? Really? Is that really too big? Oh my god. I told myself I'd make a smaller robot. I mean, I could make it a 6-wheel drive, but no, okay. Make it a little thinner. Let's see. Do that 10.5. Which makes that 26.5. 53 plus, oh, where's the clear button? Cool. And that's going to be still 65. No, 67. 120. So that's exactly it. And judging by my supreme pattern recognizing skills, that should make it 118. Okay. 254 millimeters, perfect. And I have to have these sides be 8 inches, because otherwise it would not fit the bumper rules. The ball's 8 inches, it can fit in a 10-inch space. I would rather an 11-inch space, but it's an inch. If I can't get my ball to be centered within an inch, I need to choose my design differently. Okay. Cool, so that's going to work out nicely. So my roller would be... I'm going to fit that right there. I'll center it here. It's going to be 1.5 inches tall and... sure, 6 inches long. So that's an over-the-top view of what I'm trying to do. I'm going to have a spinning roller, and there's a shaft connecting to this. Actually, what I can do now is, I'm going to just decide what my tubes are going to be. I'm doing them one at a time so I can sort of get an idea of exactly what tubes I want to make. You're going to see some obvious overlap, and I'm just going to use the trim entity tool to differentiate between the two. Okay, so let's say I'm going to close this up right here. I don't like to have short pieces of tubing, so I'm going to make this all one piece. And I just like to have my my drive side tube be pretty long. This is just personal preference. That really doesn't matter. That's how I want to do it. So I will do the same thing over here. I could just mirror it, but I already have the line tool out. Alright, that fits nicely there. And I'll do the same thing right here. And over here. Actually, I will use the mirror tool right here, because I don't want to make two other ones, and I already have other stuff I could be doing with. Oh, nope, just kidding. SolidWorks doesn't like that. Okay, you want me to do it manually. I see how it is. I tried to mirror so I wouldn't waste my time. I ended up wasting my time anyways. It's fine. Okay. Oops, line trim. Delete that. And line there. And then line there. And delete that. Cool, cool, cool. Alright. So, nice thing about this is it shows me exactly, I can get dimensions out of the way, how many tubes my robot's going to be consisting of, or at least my simple drive base. It's going to have, what, 1, 2, 3, 4, 5 times 2 is 10, plus 2 is 12. And I can just click on them, and I know, okay, it's going to be a 30-inch one, there will be a 6-incher. That's a little bit math. That's going to be 3, 10. Okay, so it ends up working out pretty nicely. And then ideally I have my ball move through the center right here. I have my wheels on the outside. Ooh, This is me not thinking right. I am not accounting for wheel space. Am I? No, I am not. So it will be a total of 8 inches. Or my total width will indeed be 26 inches. However, I have to account for my wheels. So it's going to be, what, 8 inches? I don't know how wide those wheels are going to be, so I'll give them 2 inches of space. It's not 2 inches, but I like to overestimate. And I'll make it that. I'm using West Coast products, West Coast drive bearing blocks. So the outside plate there is going to be 1/8 of an inch. I may have a spacer, or there's going to be a nub on the wheel. I'll make that 3/16. Cool. And this is, I don't know, I'll do it accurately. I should do this correctly. So I'm going to model my wheels just like this. They're rectangles, but this is a top view, so that's how it ends up working out. Okay. And I'll make that linear with that. I'll make these widths equal. I'll make the lengths equal. And I dimension them based on the distance between the wheels. Not always the best way. I usually like doing straight from center to center. But I know I'm using relatively clean numbers. And the game is driving my drivetrain dimensions, or my wheel space, to be specific. Alright. Let's see if it will let me mirror this. Alright. And I don't need to mirror this. It's not going to help my design really too much. I'm just doing for continuity's sake, and because I like doing that. I just like having full models, but that's me. Okay, so that's going to be my drivetrain. It looks pretty cool. I like it. It's going to be my roller. I'll have a roller there. Woohoo. I would have a bearing block. Will that fit? Or will I need to make that a bit longer? And I can make that longer, actually. So let me see. What is it? I think there's a half-inch radius at the end. I forget. What does this give me, though? Distance-wise, gives me half an inch. So I don't get much motion. Technically, yeah, I mean, I could run this pretty easily. That's not going to cause a problem. Yeah, I'm fine with it. I can make it work. Okay, cool. So I probably just did this without explaining it. I probably should. This 1.875 is the width of the slot I'm going to be making for a bearing block. I'm just showing the block extruding about 3/16 of an inch. That's the thickness of the plate that goes on the other side of the tube. And it seems to be working out pretty well. Worst case scenario, I don't like doing this, but I can, is I can cut into the tube. I can cut into this tube right around here. Just cut some slots in there just so it can slide in a little further. It'll be fine. Yeah. Alright, so that's going to get it there. That's how it's going to get into it. And the ball is going to... Okay, next up, I am going to model something where the ball is contacting that roller and is being pushed up into the robot. There's a few ways I can handle this. I can have something to compress it by on the outside and then just sort of hop it over. I could have a series of rollers. I want to be able to find an optimal compression for the balls, and honestly I do not remember what that is from in season, but I am thinking, I'm trying to think, thinking you can compress these guys pretty far. If I remember correctly, you could punch it pretty well. I think what we did, 2 inches of compression on our shooter, 2 or 3. So an inch or so, easy, should be pretty fast, pretty effortless. And the way I want to show compression is make a vertical line there, and a horizontal line there, and that's going to be my maximum compression. Alright. Well, that's my maximum compression there at least. Huh. So truth be told, I've actually never made an intake like this. I think I mentioned that previously. So right now I'm sort of thinking out the motion of the ball, how it's gonna, what it's gonna do when it goes through this path. I'll make that construction just so I can see easier. So it's gonna be on the ground. It's gonna get pushed up, compressed a little, and then into here. So I'm going to leave this transition alone for a while because an idea I have may take care of it. So one of the ways I want to handle the ball once it's up here is it's going to pop up, and then I'm thinking it's going to just sit on this tubing. From there it'll move out. So let's say it is on top of the tubing. Oops, okay, cool. You can do that if you'd like. So sitting here on top of the tubing, pretty simple. Problem is I have a height limitation, which is not preferable at all. I'm getting pretty close up here to my maximum 14-inch height, and that really becomes a problem if I have a ball in the center and I'm trying to go into the low bar, which I should be quite often. So I have a little less than an inch there. And if 14 is my theoretical max height, I don't want my ball to be hanging around that too much because it may fall out and something may happen. So I definitely want a ceiling of sorts just to make sure it can't go above that. But I think alongside a ceiling, just making sure that my ball physically does not go above that point, I think that would be useful as well. So if I can design my mechanism such that my ball always is contacted here, or my ball is always at an inch lower than the maximum height, if I can design with that, I don't see a reason not to. So the idea I have for controlling the ball throughout the robot is horizontal rollers. Some kind of rollers that are on the sides of the ball, and they will push it throughout either end of the robot. And it's going to be a single set of rollers. It could be a roller, it could be belts, or it could be polycord tube. Polycord's pretty annoying to work with, but it does work out. We could use an actual timing belt. We're going to use a V-belt, something that's really not... we don't need much precision with this. We just need to be able to rush it one direction or the other. I think if we really want control over this to see if the ball is exiting the robot or where it is, we could have sensors to detect ball motion. But other than that, it should be fine. So what I'm seeing is a set of horizontal rollers that contact the ball above the center point. And the reason I want to contact it above the center point is because I'm hoping by doing that it will somewhat prevent the ball from going up. I'm probably going to end up having a ceiling of some sort, maybe a thin sheet of polycarb. But I don't want that to be the only thing. So I think contacting the ball above center will be relatively helpful. So if I want my ball on this piece of 2x1, or not on this piece of 2x1, but at that height approximately, then I'll say theoretically whatever I'm moving my ball with is an inch. It's probably a little bit much, but I'll just estimate. And let's say that's going to be around, again, ooh, that's a little high. Yeah, I'll say it's around, inch and a quarter above the ball. Yeah, it looks fine. Okay. So that seems like a reasonable amount. I'm just going to get out of dimension just to get it out of my hair. So I'm going to have something that's pulling it this way. about that height. Of course, the immediate thought is a whole bunch of Banebots wheels, but I'm pretty sure those are out of the market for the time being, and that weight would add up pretty fast. So I'm thinking some kind of belt system. Belt system to move it around, spit it out. That would be pretty thin as well. That could work really nicely. Plus I only need to contact it at the ends. So I'm thinking that, and then polycarb for it to stand on, polycarb on top. And that should work out pretty nicely. So that's my thought process for this. It's getting a little past the 25-minute mark. So I'm thinking for now I'm going to end this video and continue on another one. Alright, so thank you all for watching. I'll see you next time.